When converting equations from polar form to rectangular and vice versa, we are going to use these four equations and essentially just do substitution every time in one form or another. These four equations are derived from simple trigonometry with a right triangle. You can work those out on your own if you wish to do so. Your class might give them to you just to look at and use. Either way, let's start off with a simple example. If I had the equation of a circle, let's say it was x squared plus y squared equals 9. Whether you have gone over circles or not, this is a circle with a radius of 3 centered at the origin. Don't necessarily need to know that. All you need to see is we can substitute x squared plus y squared for r squared. So, since those are equivalent, we can just say r squared equals 9. And then if we square root both sides, we would get r equals 3. Now, you might say, when we square root, we need to do plus or minus. Sure, however, whether we say r equals 3 or r equals -3, we would get the same equation. A circle in polar form, whether it's r equals 3 or -3, will still just be a circle with a radius of 3 centered at the origin or the pole. So that's a simple substitution. Now, let's say instead of a circle, let's come over here and let's say we had a slightly different equation. We'll do one of a hyperbola. Let's say we had x squared minus y squared equals 9. Okay? In this case, we cannot make this simple substitution right here. So, we're going to have to utilize a more direct substitution with x and y. So, if x is r cosine theta, then I can just substitute that in for x and say, well, r cosine theta squared minus, same thing with y, r sine theta squared equals 9. Now, this can be written as r squared cosine squared minus r squared sine squared. And what we can do now is factor out the r squared. And we're left with cosine squared theta minus sine squared theta. Now, if you're given something like this on a test, you will very likely be given this formula that I'm about to do. This happens to be a double angle formula for cosine, meaning I can convert that into cosine to theta. Now, again, you will very unlikely be expected to know that conversion in this section. You may have already done that in your class, covered those formulas, but you'll be given that to some extent, or maybe you'll just be allowed to divide both sides by that or something of that nature. But in this case, we would have r squared equals 9 over cosine 2 theta, which is just saying 9 secant 2 theta. And that would be our answer. Now, one thing to keep in mind, in polar form, you are typically expected to leave your equations either in r equals, really you want to go for r equals if you can, or r squared equals. Here, if we square root both sides, we're gonna have like a square root secant 2 theta, which isn't really gonna be considered simplified. So here you can just leave it in this form, r squared, or r equals. Occasionally, you might have theta equals, and we'll cover that in a second. But first, let's say you have just a classic y equals mx plus b linear equation. Something like y equals 2x plus 1. So, once again, when we look at this, it's pretty clear that we are just going to have to use these two. And these, by the way, are the most common equations you'll use for your substitution. This one is in a pretty particular type of problem that we'll do next. And this one will come up fairly often, but it'll be pretty obvious usually because you need to have an x squared plus y squared when it's in rectangular form. This one might come up a little more in polar form. Anyways, so when we're here, we're gonna have direct substitution. So r sine theta equals 2 r cosine theta plus 1. Notice all I've done here, y gets r sine theta, x gets r cosine theta. I'm literally just directly substituting it. Now you go, okay, polar form, I want to try and write it as r equals. So what we're going to first do is move this term over to this side. You want to think, okay, let me get all my terms that have an r on one side. So I'm going to have r sine theta minus 2r cosine theta equals 1. Now I can factor out an r. So I have r times sine theta minus 2 cosine theta equals 1. And from here, it's a pretty straightforward, you can't really do much other than divide both sides by this entire parentheses value. So we're going to have r equals 1 over sine theta minus 2 cosine theta. And that's our answer. This is typically how every linear equation is going to work out. You're going to have a number divided by something that looks like this. Now, the exception to that is when you instead have no y-intercept, meaning you have something that simply looks like, let's do y equals x. Okay, in this case, what I actually want to do here is utilize this form to substitute. I'm going to start by dividing both sides by x. So I have y over x equals 1. And notice I can now do this substitution for y over x. So y over x is just going to be tan theta equals 1. Now, this is the case where you don't even have an r in your equation. So we typically are going to write this as theta equals. That's our one other variable, right, in our polar equations. So in this particular case, we know that the tan inverse of 1 is pi over 4. Or you could just more say, ask yourself, where is tan theta equal to 1? And that is at pi over 4. Now, likewise, let's say I had something like tan theta equals root 2. Well, in that case, I would just say theta, or actually not root 2, my bad. Tan theta equals root 3. If I have tan theta equals root 3, then I would just say theta equals pi over 3. Now these are unit circle values and their subsequent angles. I personally never see this, but let's just say you had something like tan theta equals 2. And this would come from if I had like y equals 2x, right? I believe probably your best bet here in your class is you would just write this as theta equals tan inverse of 2, like that. So here's our answers to these types of questions. Now understand this is all one worked out, right? This would be if we started with y equals root 3x, we would end up there. Y equals 2x, we would end up here. Now the tan inverse of 2 does have a value if you put that in your calculator, but it doesn't really have a nice simple fraction in terms of pi, so you would probably just leave that like this. All right, let's go ahead and do a polar conversion. Let's say I have r equals 4 cosine theta. We'll do plus 1. So when you look at this, there's really no direct substitution right away. What you need to do, and this is a common problem, actually, we're just going to do this. This is a common problem where it's just r equals 4 cosine theta or r equals 2 sine theta or something of that nature. It's very common. You do the same thing every time. You start off by multiplying both sides by r. Okay? So times r times r. So on the left, we have r squared. And over here, I'm going to write this as 4r cosine theta. Now we should see that we have some substitutions we can make, right? R squared and r cosine theta. So for r squared, we can put in x squared plus y squared. And for r cosine theta, we can simply put in x. So here you have it. Now, typically from here, you're probably going to see it written like with this moved over to this side. It depends on your class as far as how simplified your teacher is going to expect this to be written. Now, I'm going to go ahead and go a little bit further because it's likely that you'll have to turn this into the standard form of a circle. That's what this is. So what we need to do is on this side, we're going to add a 4. And that means over on this side, we're also going to add a 4. And the reason we do that is, the reason we do that is we're completing the square for this portion right here, okay? Because now I can write this as x minus 2 squared. And then I can just put plus y squared equals 4. And that would be my standard form of a circle. This is a circle that's centered at 2, 0, and it has a radius of 2. So we get this all the way from starting with, remember this was just r equals 4 cosine theta. All right, another polar one that you're going to see often is essentially just working backwards from one that we already did. So let's say we have theta equals, we'll do 5 pi over 6. So if you remember, this is just going to end up being a line through the origin, but we'll go ahead and work it out so you can see how you want to show the work for this. We're going to start off by taking the tangent of both sides, and that should make some sense because then that's going to give us a conversion we can make, right? A polar to rectangular conversion. So that means I'm going to have tangent of theta equals the tangent of 5 pi over 6. So over here, I can now just make that y over x. And over here, we want to actually find the tangent of 5 pi over 6. I'm just going to quickly do that. 5 pi over 6 is right here with a reference angle of 30. That means we know this side is 1, this side is root 3, but it's negative, and this is 2. So for tangent, we're going to get 1 over negative root 3. And remember, we're typically going to write that as negative root 3 over 3. I just multiply the top and the bottom by square root of 3. So we have y over x equals negative root 3 over 3. And we finish this by multiplying both sides by x. So those cancel, and we're left with y equals negative root 3 over 3x. Once again, this is just a line that's through the origin and has a slope of negative root 3 over 3. Now, what that really is just this line. We don't really have to even count out the slope. We just know it's going to be this same line right here that has a reference angle here of 30 degrees. And you want to try and not draw it squiggly like I did, but we're doing the best we can here. Okay? Now, if I have a more simple polar one, these ones you'll see as well. Let's say you just have r cosine theta equals, let's do 5. This is just a very simple substitution. We literally can just write this as x equals 5, and that's our rectangular form. Likewise, if you were given this in rectangular form, you would want to make this substitution. However, at that point, you really just want to write it as r equals 5 secant theta, right? So this converts to that, but then if I started here, I would actually want to write it as that. The reason is when your goal is to write it in polar form, you again want it to be r equals. So it just depends on the type of question. If they start you out with this, well, that's rather simple. We know we can just go straight to here. But if they start you with this, we know our goal is going to be doing this. And remember, that's because if we divide by cosine, 5 over cosine theta is the same thing as 5 secant theta because they are reciprocals. Now, let's go back to a rectangular thing because we just went over what you would do if you had x equals 5. But if you have x equals 0 or y equals 0, very particular type of problems, this, what we just did, is not going to work. For these, you really just need to understand what it is you're graphing. Now, for x equals 0, I'm just graphing, that's a line on the y-axis. And so you literally just jump to the answer. You have to understand that this is a graph of theta equals pi over 2 in polar form, right? That's the angle that takes us there. And like we saw with the theta equals 5 pi over 6 example, you just end up drawing a full line wherever that angle lands. So likewise, with y equals 0, where we have a line that's just on the x-axis, we're just going to say theta equals 0. Or you could say theta equals pi. They're going to be the same answer. Just like over here, theta equals 3 pi over 2, or theta equals negative pi over 2. Those would all work for these particular examples. Now, the problems I just went over pretty much cover the standard problems that come up in this section. You know, occasionally you might run into something that just your teacher's testing you on something a little bit more difficult, or just something that you haven't seen. I'm just going to pick a random problem and do one for you that looks a little bit different. Let's say we had x, y equals 8. Now, sideways 8. Let's rewrite that a little better. X, y equals 8. All right. So here, we just have to start with making direct substitutions. There's really nothing else to do here. We can't turn this into y over x form very easily. I mean, technically you could, but it would get a little messier. So we're just going to go, all right, r cosine theta times r sine theta equals 8. Now, there's not much to do here. Remember, your goal, once again, when you're writing in polar form, you want to think, if I have an r in my equation, I want to write it as r equals, if I can, or r to some exponent if I have to, like r squared or maybe r cubed. If I don't have an r in my equation, then I'm going to want to write it as theta equals. So in this case, we do have an r. We know that these are all just multiplied together, so we could write this as r squared cosine theta sine theta equals 8. And now all we really have to do is divide both sides by cosine theta sine theta. So remember, that means I can write it as r squared equals 8 secant theta cosecant theta. And that's just, once again, because secant and cosecant are the reciprocals of cosine and sine. So there you have it.